Right, good afternoon everybody. Welcome to day 2 of our bioinformatics lockdown learning. So, hopefully we're online and people can see me. I'm going to try today to have the live chat around if possible. I think I kind of failed at that yesterday. And so I'm going to try a little bit to try and monitor what's going on there if I can, although obviously I've got a load of stuff all going on at the same time here. Okay, so good afternoon in the UK at least. Don't know if it's afternoon where you are, but we'll see. Okay, so yesterday we began by installing a virtual machine manager. It's a piece of software called VirtualBox, and then using that software to install a Linux virtual machine. So in our case, we've installed an operating system called Ubuntu as a virtual machine. So I'm going to just pop my VirtualBox window up here. So this is VirtualBox, and we've installed this Ubuntu virtual machine inside our VirtualBox here. At the moment, my virtual machine is powered off. The other thing that we did yesterday afternoon was we set that virtual machine up so that it can share files with our host file system, so that we don't need to give it a huge hard drive. We've just given it a 10 gig hard drive, which is just about big enough to hold the operating system. And that means that all of the files that we create in that shared folder that we made yesterday are available both on the virtual machine and on our host operating system. So in my case, my Mac laptop. I know from the correspondence that I've had since the end of the live stream yesterday that for some of you that process went very smoothly and worked very well, and for others that was perhaps not the case. So I know that there are some people who did struggle a little bit with getting to the point that I was at the end of yesterday's video, and that's entirely through no fault of their own, because this actually turned out to be a much trickier thing to do than I had anticipated. And partly that's because I can't test this setup on all sorts of different configurations. So I've got a Mac laptop. I do have a Windows machine, but it's not powerful enough to run this kind of thing. So I've not tested this on Windows at all, and I know that there was some problems with people who were running on Windows. And also, my own laptop is a couple of years old, and as a bioinformatician, I'm always doing things like this. I've run virtual machines before. I've had this kind of setup before, so I've probably done some setup on my laptop in the dim and distant past that I can't really remember having done. And so, although this all works nicely on my system, it isn't necessarily a given that it's going to work really nicely on everybody's. What I would say is, I think for a lot of people, we've managed to debug problems as much as possible. So there's been quite a few emails that I've received and comments on the YouTube video that I've received that I've tried my best to try and address and get people up and running into this point. So if you are still at a point where you haven't quite got a working setup that I had at the end of yesterday's lesson, then do get in touch. I want to make sure that as many people as possible can follow along with these tutorials. I would also say that that's probably the most fiddly thing that we will do. I think full stop, actually. Certainly the most fiddly thing that we will do for a while. So if you can get over that hurdle of that first lesson, then everything should get much smoother after that. What we're doing today and what we're doing for the next few days should not present anywhere near the same level of technical difficulties, because once you've got a working system, then all of the other things that we're going to do over the next few days should be relatively straightforward. So with that in mind, as I said, if you've still got issues with your setup, please do get in touch, and I will try to get those things sorted. The other thing that I would say is that, as I said yesterday, my aim here is to take this deliberately slowly, that I'm not going to rush through a whole load of stuff very, very quickly. So if you do get, if it does take you a day or two to get to a working system, then catching up should be hopefully really quite achievable, that you're not going to be so far behind that and we've done loads and loads of different things and kind of left you in the dust. Catching up should hopefully be really okay once you get a working system. So that's, I think, yesterday dealt with, and as I said, I hope lots of people are going to get to a point with a working system very, very soon. So on to today, and what I wanted to talk about today was the Linux file system. So we've just installed a Linux virtual machine. So Linux is an operating system. It's an open source operating system. So unlike Mac OS and Windows, which are commercial operating systems, and actually, although very often the updates of those operating systems are free now, they're very dependent on the hardware that you buy them with. So when you buy your PC, you're also buying a copy of Windows. You may not necessarily realise that that's what you're doing, but you are paying for access to Windows. And similarly with Apple, with the Mac OS, the Mac operating system, you don't have to pay to update that operating system once you've got it, but you do have to pay to buy a Mac to be able to run it in the first place. And so part of the cost of buying that hardware is your cost of accessing the operating system that's running on it. Linux, on the other hand, is an open source operating system, which means that there is no cost, so it's free as in beer. There is no cost associated with running that operating system on any hardware that you're capable of running it on. So in this case, we're running it in a virtual machine, so actually the hardware running underneath is almost irrelevant to us. There's also it's also free as in speech, which means that it's open source in regards to you can read the source code of the operating system, and if you want to, modify the source code of the operating system. So it's a very open way of working, and in that regard, really quite different to the other operating systems that you might be used to. Linux has been around since the 1990s, and it's a development of an earlier operating system from the 1970s called Unix. So Linux mostly sits on top of Unix and is a Unix-based operating system. Mac OS is also a Unix-based operating system and does actually have a lot of features in common with Linux, but as I said, is not open source and doesn't necessarily let us do all of the things that we want to do during the progress of this course. Linux is as I said, a Unix-based operating system. It was developed in the early 1990s and is surprisingly popular. I think it is probably the best way of summing it up. You probably use a Linux system in some way, shape or form every single day without really realizing it. So almost all of the internet, for instance, runs on Linux servers. All of the top HPC systems in the world all run on Linux. Linux is an embedded system in lots and lots of different devices. So, and Android is effectively a Linux operating system. So if you have an Android phone, you effectively have a Linux operating system on your phone. So it's a it's much more pervasive and much more popular than you might expect, especially if you've not really heard of it before this week, which I accept is entirely possible. Linux is popular in bioinformatics for lots of reasons. It's the lingua franca of scientific software. Scientific software tends to be developed on a Linux system and tends to be distributed for Linux systems as a first-class citizen. So it's not always the case that there will be a Windows version of a particular piece of software, but there will almost certainly always be a Linux version. So it's a good first port of call to making sure that the software that you want to use for whatever it is that you're trying to achieve is available to you. And Linux is great for that. And that's the reason we're using it here, is all of the software that we want to use over the next few weeks is all available natively on Linux, which is really helpful to us. We also tend to use command line versions of tools, and there's lots of reasons for that. So if you're using lots of your CPU cycles to make a graphical user interface, then you've got less of them to spare to actually run the tool and do what the tool wants to do. So we tend to use command line versions because they tends to be the native way of running those tools, and it tends to be much more performant. It's much more efficient to run something at the command line than it is to run it in a graphical user interface, which itself is using lots of the resources of your computer. So that's why I'm kind of going to run these courses in the way that I'm running them, which is that what we're going to do over the next few lessons is get to know the Linux command line a bit, get to know how it works, what the tools are and how those tools work, and then we will use command line tools to achieve some of our goals. And then in future, so after we've kind of got a long way with that data processing side of things, we will work towards using R, which is a programming language which is able to run in Linux as well as Windows and OS X, and is a statistical programming framework which we will use for analysing data, for data analysis. So we'll do a whole load of data processing in using our Linux tools, and then we'll move on to using R to analyse that data that we've processed. Okay, so so Linux has been around since the 90s, as I said. Ubuntu, which is the distribution of Linux that we're using here, was first released in 2004. And Ubuntu is a company that was set up to try and make desktop Linux much more accessible. So before Ubuntu came along, running Linux on your desktop machine was an incredibly fiddly enterprise, and was really quite difficult to do, and something that only really expert users would even begin to try. Ubuntu was set up with the aim of making that much more accessible to everyday users, and the point at which we've got to now, which is the installer that you saw yesterday, admittedly for Xubuntu or Xubuntu, which is a slightly different version of Ubuntu to the main one that you can download from ubuntu.com, but very similar. That installer is incredibly easy to use and very slick, and actually it's telling that the problems that people had, most of the problems that people had yesterday, were related to either VirtualBox and getting VirtualBox to work properly, or with getting the folder sharing working properly. They weren't with installing a Linux operating system, which is incredible to me as somebody who saw how this worked 15 years ago, where we would have spent days and days and days getting the operating system installed. and working properly, whereas now that's an incredibly slick process. And there are lots of companies in the Linux space who are working on making that experience really smooth and making it work very well. And Canonical, who develop and distribute Ubuntu, are by no means the only company doing that, but to a certain extent, that's kind of where that movement really began. And there are other companies like Red Hat, which is owned by IBM, and other people besides who are doing very similar and really, really good work in this space. And collectively they've made made Linux, sorry, a much more accessible operating system than it used to be. So at this point, I'm going to bring VirtualBox back up onto screen, and I'm going to kick off my virtual machine. So I'm going to start my virtual machine up in order to start to show you some things about the file system today, which is the main topic that we're going to talk about for the remainder of today's lesson. So here's VirtualBox again, just like we had yesterday. I've not done anything to my setup since yesterday, apart from I've slightly changed the setup of my terminal. So when I start my terminal, hopefully the text is going to be nice and readable for everybody on the live stream. So I'm going to hit start, and that will boot my virtual machine. So my virtual machine will start up, and Ubuntu will begin to boot. Sorry, Xubuntu. I keep forgetting that we're using Xubuntu, not Ubuntu. So Xubuntu will boot, and hopefully this won't take a terribly long time. As I said, I've done nothing in particular to the setup since we finished yesterday afternoon. So Xubuntu is booting. As a reminder, I've got my shared folders as well. So here I've got my lockdown learning folders, which are shared between my virtual machine and my host machine. But I'm not worrying too much about that today. We'll come back to that in a future lesson. It was just important setup to get done yesterday to make sure that we're all ready to go in the future. So I'm mugging slightly to the camera here because my virtual machine is taking a while to boot up. So off we go, and there it is. So here's my VM. We've got my home directory here, so I can open up my file system. There's my share that I set up yesterday, so that's all still there and intact. I've also going to open the terminal. So by clicking the mouse in the top left hand corner, that little mousy icon, which is the symbol of Xubuntu. So if I click that and then scroll down to this terminal emulator, this is my terminal program. And the terminal is the place where we will spend most of our time in the lessons over the next few weeks. So I'm going to click on the terminal emulator, and up pops my terminal. And as I said, the one big configuration change that I've made since I last spoke to you is that I have made the text in my terminal quite substantially bigger. I've also changed the color of the text as I type in my terminal to be much higher contrast. So hopefully that's more visible to people on the live stream. If this is still, if this can still be difficult to see for people, then I can actually try to kind of up my text size even further. I want to make sure that everything fits on the screen though, so I want to be a little bit careful about that. But hopefully this is all legible for everybody on the live stream. Okay, so I'm going to talk about the Linux file system a little bit and about how Linux stores all of its files and how the file system works. So in Linux, every single thing about the operating system can be thought of in terms of a file. So all of the configuration is all stored in files. A directory, so a folder, is also a file. It's just a special type of file that's able to contain information about other files. all of the programs that you run can all be thought of in terms of an individual file. And this file system, as it's known, is incredibly important to the way that the operating system works. And Linux, the file system, has a very, very rigid structure that all Linux distributions follow, and they all look the same. And we tend to think about them in terms of people talk about it as a tree. So it's a hierarchy. So you think about it in terms of a tree because you think about kind of branch points and levels and leaves and things like that. So people talk about it in terms of a tree, but unlike a tree, the root is at the top of the tree. So I'm just improvising a little bit here. I'm using OneNote, and I've got a tablet which I'm going to draw on. So I'm going to try and kind of write stuff live for you. So I'm going to draw a picture of the Linux file system, and that picture hopefully will show you what it looks like and how to work around the Linux file system. So we think about, as I said, we think about it as a tree, but we kind of think about it as an upside down tree. So at the top of our tree, I'm just going to check that my OneNote is online, otherwise this really isn't going to work. Okay, this may not work, in which case I'm going to have to think of some other way of doing this. No, here we go, maybe. Bear with me. Teething troubles. So hopefully what we should see is, I'm going to draw a box, and in that box is going to be the root of our file system, and this really isn't going to work, so I'm going to try and draw on my Mac instead. This is going to be an interesting experience. Okay. Okay, here we go. So we're going to draw a box at the top, and that box is called our the root of our file system. So that the root gets this symbol of a /. Let me just see if I can sync these things up. If this isn't going to work, I'm going to have to drag in a PowerPoint. I didn't really particularly want to do that, but we'll see what we can do. Because that drawing with a mouse is really not the way to do this. Okay, so this is the top of our tree. The top of our tree is the root of our file system, and that takes this symbol /. Okay, so here we've got /. I've drawn it in a box, and although it doesn't look very neat, it's kind of the best I'm going to be able to do, I'm afraid, today. I'll try and get this working properly for future lessons. Okay, so after that /, we have directories, and directories are special types of file. They're able to contain other files, and they sit under the root of our tree. So we're going to draw a little hierarchy here. So across we go. That's meant to be a straight line. Here we are. We're drawing a little tree, just like a phylogenetic tree, like this. And then each of these is a directory. So we're going to draw a box for a directory. So the root directory, so this /, that's a directory as well, just like all of these things. So in here, in each of these, we have different bits of the file system. Okay, so each one of these boxes is a directory, and in each of those boxes we have different types of files. So we have a directory called etc, and that contains all of the configuration of our file system. So that contains all of the settings files and everything for how the operating system works. We also have a directory called bin, and bin contains what's known as the binaries. So bin is short for binary in this case, and the binaries, they're the programs that run our operating system. So in this directory called bin, we have a whole bunch of programs that let us do things in Linux. Okay, we also have a directory called, let's say, we've got user, USR. So user contains more directories, and these are all things to do with the users on the system and how things that are special for those users. There's other directories in here called things like local, and there's a bin directory in there as well, which also contains other binaries, and binaries which are more specialized and less system-wide. And then the final directory in here that's really, really important is a directory called home. Okay, so this is a directory which contains all of the files that belong to the users of the system. So in your operating system, in your Linux operating system, you have in your home directory, you have another directory, and here goes my shonky drawing again. Totally exactly the way that I wanted to do this, really, I promise. Here's another box drawn with a trackball mouse. There we go. In there, so this is a directory that lives inside our home directory, and in there will be a directory which has your username. So in my case, on my Ubuntu system, my user is called Simon, so I have a Simon directory in there, and that's where all of my user files live. That's where all of my files that I create live in there. So again, a bit more drawing. Bear with. Do apologise. Here we go. 1, 2, 3, 4. Dare I say I'm getting slightly better at it. Oops, spoke too soon. So one of the directories that's in there is called, here we go, is called share. And that's the directory we created yesterday that we share between our two operating systems. Okay, so we've got this tree, and this tree contains directories, and it also contains files. So I'm going to go back to my virtual machine in a moment and show you what I mean by this. But this is our tree structure, and in there are all of the files that make up the operating system. So all of the configuration, all of the programs, everything that is involved in making the operating system function is contained within this tree. There's nothing outside of it. There's no second tree that contains other information. It's all in this one place, and it all sits under this root. So this /, which denotes the root of our file system. So at this point, I'm going to jump back to my virtual machine here with my terminal, and I'm going to show you this structure in my virtual machine. Okay, so I'm going to, first thing I'm going to do is I'm going to type the command pwd. So this is our first, other than the things which I just got you to type verbatim yesterday, this is the first command that you're typing in anger that I'm going to explain exactly what it is that it does. So pwd stands for print working directory. So what this command does is it will, on the screen, when I type enter, it will print the current directory that my prompt is sat in. So my little terminal here is sitting, resting within a directory on my file system, and that directory, by default, when I log in to my virtual machine, is my home directory. So if I print my working directory, having done nothing else after logging in, what will get printed back at me is my home directory, which should be, as I drew shonkily in my picture, should be /home, and then everything here is separated with a delimiter, which is a /. So you've got /home /Simon, and that's my present working directory, because that is my personal home directory. Okay, your home directory will be called something slightly different, presumably. So your home directory will be /home/ whatever your username is. So you can see I've hit enter here, and it's printed my working directory, which is /home/Simon, as predicted on the other screen. So that's my home directory. That's where, when I log in to Ubuntu and open a terminal, that's my present working directory, and that will always be my present working directory after a login. Okay, so in order to show you a bit about the file system, I'm going to move around that file system. So I'm going to navigate around the file system at the command line. And the way that you do that is using the command cd. Okay, so this is our second command. So our first command was pwd for print working directory, and our second command is cd, and cd stands for change directory. So pwd just reports where you currently are in the file system. CD allows you to move around the file system. And again, you will do this by writing out a path, so a place on the file system where you want your prompt to go, where you want your terminal to go. So in this case, I'm going to CD to the root of the file system. And if you remember from what I've said already this afternoon, the root of the file system is denoted by a single / character. That is the root of our file system. So if I type cd and then a space and then a /, my prompt will be moved from my home directory to the root directory of the file system. Okay, so cd and a /, when I run that command, nothing really appears to happen. So I'm immediately returned to my prompt, and nothing much seems to have changed. Nothing is printed out to the screen. There is one change that is very subtle, and that is that the character before the $, so the $sign is saying enter your text here. The character before that is telling me where on the file system I currently am. So previously I was in my home directory, and the short name for your home directory is this tilde symbol, which is here before the $sign. So tilde means home in this regard, which is /home/Simon in my case. I've changed directory to the root directory, and that tilde on this line here has changed to a / on this line here. That's telling me that my prompt is now sitting in the root directory. And to confirm that, I can again run the pwd command. So again, if I type pwd and hit enter, then it will report my present working directory, my current working directory. And this time, instead of being my home directory, /home/Simon, it is instead just a single /. And that's the terminal telling me that I am sat in the root of my file system. So /. Okay, so on to our third command. So far we have run pwd for print working directory, and we've typed cd for change directory. Our third command is ls. Okay, so ls is a command which allows us to list the contents of our current working directory. So if I type ls and press enter, then my terminal will give me a listing of all of the files and directories that are held in my present working directory. So in my case, at the moment, my present working directory, as we can see on the previous line, is root / single /. So if I list the contents of that directory, we will see those directories that I talked about before on the previous screen. So we will see this etc directory, and we will see this bin directory, and we will see our home directory as well. So if we jump back over here and I execute the ls command, then you can see actually quite a lot of things here. So the directories that I talked about before, and directories, when you run ls, the way that we've got things set up is directories are listed in this dark blue. So the dark blue color is for the directories. The lighter blue colour is something called a link. So that's a link to another file. The white is they're just files. So they're not special, they're not directories, they're not links, these are just normal files. So that's white. And the green is showing you something else. It's showing you that this is a file or a directory that has special permissions. Actually, the green background is showing you this is a directory that has special permissions. But we're not going to worry too much about permissions right now. We will come back to that in a future lesson. So for now, just worry about the dark blue and the white. The dark blue tells you that this is a directory, and the white tells you that it's a normal file. And you can see that most of the things in the root directory are themselves directories. Okay. Incidentally, if I list one level above, so ... means one level above. Again, I'm going to come back to that later. That didn't do what I expected it to do, so forget that. Yes, these things are going to happen when you're doing it live with no script. That didn't do what I expected it to do. Root is also a directory, by the way. So the / the root is a directory itself, which is in itself is a useful piece of information. But here we've got a load of directories that are stored in root. These are our system folders. Mostly we don't have permissions to change or move or do anything to any of these files. So I'm showing you this for information. So with our ls command, we can give ls a second piece of information, which is the directory that we want to list the contents of. So by default, ls will just list the contents of the present working directory. But if you say you want to list, if you name another directory that you want to list the contents of, then ls will change its behavior and it will list the contents of that directory instead. This is called an argument. So an argument will change the behavior of a command. And in this case, we're giving the ls command an argument, bin, which allows you to list the contents of that bin directory. So the bin directory contains, as I said before, contains programs. It contains files, but those files are programs, which are the kind of programs that are very high level and very involved in running the operating system. So there's a lot of programs in here which we don't need to worry about yet. And these are all files. They're green because they're executable files. That means that we can run them as programs, and that's why they're green. And actually one of the files that's contained in this directory, and there are lots of them, but one of them is ls. So that's the program that we were just using. So the ls file is contained in the bin directory in the root, and that's a program. So when we type ls, it executes that file. And runs it, and that runs the program ls, and that program has particular behavior, which in the cases we've seen so far is to list the contents of the current working directory. I've seen somebody mentioning ms-dos in the comments. The equivalent for ms-dos is the dir command, so dir, which will list the contents of a directory. Now on DOS, ls actually does work. They've got dir and ls are kind of aliases for one another, but DOS and Unix share very similar roots, so there is a lot in common between them, and working at the command line is kind of the oldest way of working. Okay, so that's the root directory. The root directory contains lots of these subdirectories. The one that we're most concerned with for the purposes of today is the home directory. Okay, so in the home directory, and if we list the contents of that, you will find that on your system that we installed yesterday, so it's a brand new system, you will have a single user, and that's the user that you set up when you created the machine. So I created a user called Simon. So in my home directory, I have a single directory which is called Simon. That's my personal home directory. If there were other users on the system, they would all have their own directories in that home directory that would be their personal home directories. I'm gonna cd back to that home directory, and we can do that in lots of ways. And this is about navigating that hierarchy, so working our way down that tree of files. So we're in the root directory at the moment, and our prompt tells us that. And if we're not sure, or if we're on a different machine that might have a different prompt that isn't set up to be quite so friendly, pwd will tell us where we are in the system. So we're in the root. So we want to get back to our home directory. There are lots and lots of ways of doing that. The first thing I'm going to do is I'm going to cd, and I'm going to cd into the home directory. Okay, so I'm in root. The home directory is a directory inside the root directory. So to cd in there, I type cd and then the name of the place I want to go, which is home, and that will take me into the home directory. And now, again, if I type pwd print working directory, you'll see that I'm in that home directory. So my current working directory has changed from a / before now to / home because I've moved in the file system. The next thing that I want to do is to go into my home directory, and to do that I'm going to cd into Simon, which is my home directory. Okay, and that takes me back into my home directory. My prompt has now changed back to the tilde symbol, which is telling me that's the shortcut for home, so that's telling me that I'm in my home directory. If I type pwd, I'm back in /home /Simon. So I'm back home, which is a nice, comforting place to be. In my home directory, I have folders and files. So again, I can type ls to show me the folders and files that are inside my home directory. The one which we really care about in the context of this, of what we're doing here, is this share directory that we created yesterday. But there are other directories that are created by the system when we installed it. So we've got a desktop directory. Anything we put in the desktop directory, as the name suggests, ends up on the desktop of our operating system. So we've got desktop there. So all of those files that we see on our desktop, they are all files that are inside that desktop directory. If I create a new file in there, and I'm just going to do that like this, desktop /file, it will appear on my desktop, and there is that file that I've just created. Okay, I'll come back to touch later, don't worry about that too much at the moment. Okay, so that's our home directory. The share directory is, as I said, the most important one. That's where we're going to create all of the files that we make. So I'm going to cd into the share directory. If I want to go back home now, again, as I said before, there are lots of ways I could do it. I could just type the full path of my home directory, /home /Simon, and that would take me home. I could use the shortcut, this tilde symbol. That's a shortcut for home. So if I do cd tilde, I'll find the tilde on my keyboard now. There it is. So tilde, that takes me home as well. So that will take me back to my home directory, wherever I am on the file system. It could be somewhere really complicated, and cd tilde would take me home. And actually, the default behavior of the cd command, without any arguments at all, so remember these things that you have after the command are called arguments. So cd share is an argument for the cd command, and saying change my directory to a directory called share. The default behavior of cd with no arguments at all is to take you home. So if I run cd on its own with no arguments at all, my prompt will return to my home directory. So we'll go back to this being a tilde here, and if I type pwd, I will be in /home /Simon. So I can cd around my file system. So if I cd to root user local bin, okay, so this is a fairly common place where if I install programs on my Ubuntu machine, this is where I would usually install them if I want them to be available for all other users. It's a place which is kind of used for those locally installed programs. In user local bin, currently empty because I haven't installed any programs, but it's a different place on my file system. I'm nowhere near my home directory. I'm several places away from it, but just typing cd and return will get me back to my home directory. So again, just typing cd on its own with no arguments takes you back to your home directory. So I'm back in /home /Simon. I'm just going to cd back to user local bin again for a moment. So I'm back in there. It's an empty directory. pwd reports my present working directory as user local bin, and I'm going to cd back to my home directory, but this time I'm going to do it by using what's called a relative path. So most of the paths that we've been typing, or a lot of the paths that I've been typing so far have been absolute paths. So they begin with a /. Okay, so /user /local /bin is an absolute path to that directory on the file system. A relative path, on the other hand, doesn't begin with a /. So cd share, that's a relative path. I'm not telling it absolutely on the file system where this share directory lives. That would be /home/simon/share, so a path that begins with a /. This is a relative path. So this is cd to share relative to my current location. And there are lots of ways of defining relative paths. So you could do it just with the name of a directory that's in your present working directory like this. You could also use the ... notation. This takes you one level up that hierarchy. So ... takes you to the directory above your present working directory. So I'm presently in bin. ... takes me to local, which is one above bin. And ... after that takes me to user. So from bin, the ... takes me to local, the second ... takes me to user, and the third ... takes me back into the root directory. So that takes me back to the top of the tree. And now I can work my way back down the tree again by going home. So I'm going to go from root into home and then into Simon. And that will take me home by a fairly convoluted relative file path. So I'm going to go back up the tree to root and then back down into my home directory. And that's what that command will do. And now again, if I report my current working directory, it's /home/Simon. Some people in the chat are recommending tree as a visualization of the file system, and I do really like tree, and I was at some point planning on showing you it. So tree is a command that will print you a nice little representation of your file system. By default, I don't think it's installed on Ubuntu. Let's have a look. No, it's not. So by default, tree isn't installed. So at this point, we're going to install this application, this binary, this program. And to do that, we're going to use a package manager. So one of the really nice distinguishing features of Linux operating systems is they have this thing called a package manager, which is like an app store. It's like a way of installing programs, and we can use it from the command line. On Ubuntu and on systems like Ubuntu, the package manager is a program called apt. Okay, so we're going to use apt to install this program called tree. And we're going to do that by running the command that's suggested. When we tried to run tree, it said, oh, we can't find tree, but you can install it with this command. So we're going to run that command. So sudo, which we came across yesterday, sudo is a way of running a command as an administrator. So by typing sudo in front of your command, you're going to run this command as an admin user of the computer. Whenever you first run a sudo command within a particular time frame, you'll be asked for a password. So when I run this, I'll be prompted to type in my password. Apt is the program that installs. That's my package manager. So that will install my software. Then install and tree. And so this tells apt. So these arguments, install and tree, are arguments for the apt program, and they tell apt that this is the behavior I want. I want to install this program, and the program that I want to install is called tree. When I run this, I'll be prompted for a password. So I'll type in my password, and it will apt will go away and download the software. So it will download tree, and it will install it onto my system. And now I've got the program tree, and if I type that command, I will get a little display of my file system. So this is showing you I'm from my current working directory, which is my home directory. This is showing you what's contained in that home directory in a little kind of, as much as a terminal can manage, a little kind of graphical view of what's present in my home directory. So this is showing me the files and folders or the files and directories in my home directory. Okay, so desktop, documents, downloads, and our share directory is there too. If I cd to root, so cd / and then run tree, it will show me all of the files on my file system. That will be a lot, even on a freshly installed system where we've not done very much to it, that will be an awfully large number of files. So if I run this now, it's going to print out a lot of things, okay, because there's an awful lot of even on a freshly installed system, there's a lot of files and folders. But you do get an idea from this of the hierarchy, because it's showing you the different levels of the file system with these vertical lines down the left-hand side of the screen, showing you all of the different levels of the file system and what's contained within it. So that has printed out every single file and directory on my entire system, okay, which is a lot of files and folders. You can limit that, so you can say just show me it to a depth of 3 directories, so just descend into 3 levels of directory. Why did that not work? Okay, remember my configuration of tree by looking at the man page. This is something else I'm going to talk about in a future lesson. So actually it wasn't D, it was L, which is how deep you want to go. So rather than D, it's L, and I'm just going to go 3 levels deep. And that will show me, so rather than showing me every single file on my entire file system, it will just descend into 3 levels of directories and show me all of the directories and files at that level. It's still a lot of information, but it's a lot less than showing the whole thing. And hopefully what you can see from this is the hierarchy of that file system, and the kind of depth to it. If I just cd into the home directory and again type tree, you can see that in the home directory there is a directory called Simon, that's my user, and in that Simon directory there's a whole bunch of other directories. So it's a nice little visualization of the file system, and thanks to the person who mentioned that in the comments. Okay, so what we've done over the last 50 minutes or so doesn't feel like a great deal, I will freely admit, but we've looked at the kind of structure of the file system, tried to explain a little bit about how the file system is arranged, and I've also shown how to navigate around that file system. So we've just looked at 3 commands, 4 commands if you count tree. So 3 commands. That is pwd to print your working directory. That tells you where in the file system you are currently located. Okay, so print working directory. And at the moment you can see I'm in /home. Then we've got the cd command for change directory. And cd will move you around that file system. So currently I'm in /home, and I want to be in my personal home directory. So to do that, I'm going to run the cd command with no arguments. That will take me home. And then the final command for kind of orientating ourselves within this file system is ls. And ls shows me the files and folders, the files and directories that are contained within my present working directory by default in its default mode of operation. So ls will list the contents of the present working directory. So that's showing me the other directories that are contained within my current directory. It would also show me the files that were there if I had files as well. What we're going to look at tomorrow is ways of working with files and directories. So we're going to start tomorrow to create files and directories and to look at how to move them around and copy them and do those kind of file operations. We will continually come back to the commands that we've introduced today. So cd, ls, pwd, they will be staple commands. They'll be things that we'll come to again and again and again. So understanding their behavior is really important, and we will go into more depth about their behavior in future lessons as well. We'll look at what arguments are and what options are in future lessons. So we've looked a little bit at arguments today. So if you give an argument to ls, it will, instead of listing your current working directory, it will list the directory that's named in your argument. So ls / will list the contents of the root directory. So that / is an argument that we've given to ls to change the behavior of ls. That you can also give commands options, and options will also change the behavior. And we will look in future lessons at what options are, how to find out what options are, and how they change the behavior of different commands. But that's all from me today. So I realise that as I've said repeatedly over the last 2 lessons, we are going to take it slow, and this is very much taking it slow. So we've shown you 3 commands today. We've used those commands to navigate around our file system, and in doing so, I've tried to explain a little bit about that file system and how the file system works. I will try to get my setup for drawing things so that you can see what I'm talking about, so that I can actually use a pen rather than a mouse working properly for future lessons. I'm sorry about my really shoddy drawing with my trackball, and I'll do better in future lessons. So come back tomorrow for a lesson on working with files, so creating files, moving files around, copying them, and also how to put some contents in them, so how to actually edit files and start to create some data. So that's what we're going to do tomorrow. And then hopefully by the end of the week, we might start to look at how we're going to download some data, either by the end of this week or early next week anyway. So thanks again for dropping in today. I have been able to watch some of the comments and monitor some of the comments, and it's been really nice to see that today. So I've done a little bit better at the business of being a live streamer today, and thanks for your comments. It's really nice to know that there are people out there watching, and I hope to see a whole load of you again tomorrow. Thanks for dropping by. Stay safe and keep well, and see you tomorrow. Bye everybody.